on. Two or more equations that are true at the same time. The reason why I say two or more is because after break, we will talk about solving systems of three equations, okay? Which all it is you do elimination twice. It's kind of cool. So. But for today, all of our equations are going to have, or all our systems are going to have two equations. The solution. This is key because sometimes, especially on a test, if it's a multiple choice, if I ask for the solution, sometimes you don't have to go through the math part of it. A solution is any ordered pair that makes all equations true. Some of you who are in here on, I think it was Thursday, for flex, we talked about this a little bit. Do you remember that?
Yeah.
How you can plug ordered pairs in, but it's got to work in both of the equations in order to be a solution. So make sure that it is doing that. Okay, there's kind of two schools of thought. There's substitution and elimination. Honestly, I don't use substitution a whole lot. I'll show you when you would. And quite honestly, this case, I would probably personally use elimination, but I'll show you how to use substitution. The idea of substitution was you get one variable alone in one of the equations, and then you substitute it in the expression in for the variable in the second equation. So for instance, couldn't I add 2y to both sides on the bottom, and then I'd have x equals 10 plus 2y, agreed?
Yeah.
Or on the top, couldn't I subtract 3x from both sides?
Yeah.
Okay, so that is the idea of substitution, that you can easily get one variable alone. I'm going to do the bottom row and get the variable alone, so I'm going to add 2y to both sides, and then I get x equals 10 plus 2y. Are we all in agreement there? Okay, so the word substitution means we take something out and we put something in its place. So what we take out is the x, and what we put in its place is 10 plus 2y, and I want to do that up there. Okay, so I'm going to take that x out. There's still a 3 times x. Put it in its spot. Don't forget, that's my x. Then I have my plus y there equals 20. Are you guys remembering this?
Yeah.
Did anybody solve it using elimination? Did you? Okay, it is in most cases, but down here I'm going to show you how you really want to use substitution. Okay, we'll get to elimination tomorrow. 30 plus 6y plus y equals 20. I get 7y equals, I know I'm going fast, guys. 7y equals negative 10, yes? Y equals negative 10 sevenths. Okay, let's just leave it like that. I'm not done yet, though. A solution has to be an ordered pair. What do I need to find? X. So I go back to my original equation that I had x alone, and I just plug it in. So it's 10 plus 2 times negative 10 over 7. Just because it's always good to practice fractions. This is 10 minus 20 over 7, agreed? I'm going to put this over 1. I'm going to multiply by 7 over 7. What's 70 minus 20? This is 50 over 7. So your ordered pair is 50 sevenths, comma, negative 10 sevenths. Okay. Now, something that's new this year for the next example is on the SAT and PSAT, you can use Desmus. So I will show you how you can solve quadratic systems with either factoring or quadratic formula or graphing. And if graphing is an option, I would use it. Okay, so first of all, we've seen this problem before. Let's think of a rectangle. We're going to write an equation for perimeter and area. What would be the perimeter? If it has a perimeter of 100, what could be an equation for that?
X plus y.
Careful.
X squared plus y squared.
2x, I think, is what you mean, right? X plus x, 2x plus 2y equals 100. And for area, okay, x times y equals 300. So if I'm going to use substitution in this case, I guess you could do either one, but I think what I would do is the top one. First of all, I'm going to divide both sides by 2. That leaves me with x plus y equals 100. Give me some indicator that you're following that. I know I don't want to go too fast. Okay, I divided everything by 2.
50.
Oh, poop. You're still out there. Good. X plus y equals 50. All right, now I'm going to get one of my variables alone. So I'm going to write y equals 50 minus x. We still good? And now I'm going to substitute that y equals 50 minus x in for x down here. So I have x times 50 minus x equals 300. So I go through and I distribute 50x minus x squared equals 300. This is a quadratic now. The one above was linear, right? So if I graphed the one above, it's 2 lines. If I graph this, it's a line and a hyperbola, but solving this is a quadratic. And so how could I do that? Quadratic formula, right? Or graphing? I'm going to do graphing just so you see that. Remember how to do that. So if I'm solving a quadratic and I'm using quadratic formula, I want to have a 0 on one side. So if I did that, I'd have x squared minus 50x plus 300. I don't know. I haven't taken the time. That might be factorable. But. All right. So we're going to hop over to, I use my graphing calculator. I know you guys like Desmus. But I can't put Desmus underneath here, so. Whoa.
Shut up, Paul.
Whoa. All right, so real easy way to do this is x squared minus 50x plus 300. If I wanted to, you can use the 0 function, or you could put in 0 and use the intersect function. 0 is the x-axis. I'm trying to figure out when this equals 0. Where's the other one? Oh, what happened? Here, we'll start with that. Okay. I'm going to find its intersection. I know I don't have the whole thing on there, so I do that. 1, 2, I guess. I can find the one because it will tell me the other one from that. It's 6.973. Oh, so does mine. Thanks, Drew. 6.972. All right, if I wanted to find the y then, hey, was there another one when you zoomed out? Mr. Desmus? Was there another one when you zoomed out?
Oh, yeah, there is.
What is it?
43.9.
I think so, but let me double check when I plug it in. Question?
Yeah, isn't it negative 300? Isn't it minus 300?
I actually moved these two things to the other side.
Oh,
But if you did the other way, you should get the same, you would get then x squared plus 50x minus 300, but it should give you the same solutions. Okay?
No, it's
Okay, it was crucial. Yes, when I also noticed that the other solution is the y. Do you see that? When I subtracted it, so. So the other way that you could solve this is you could run this through quadratic formula. You remember that?
yeah.
Cool. All right, so then the last thing I want to show you is another nonlinear system. This one's a cubing function and a line. So this is substitution, even though some people don't really see it as such because the y's are just alone. So I usually just say, hey, if they're both equal to y, then aren't those things equal to each other? But really what you're doing is you're substituting the y up there for 3x. So I want to find when does 3x equal x cubed minus 6x. If you wanted to solve this graphically, I'll show you this one. You could graph 3x, which is going to be a line, and then x cubed minus 6x is going to be a cubing function. And then that's the line. That's the cubing function. How many solutions does this look like it has? 3. Okay. I'm going to show you algebraically how to solve it, but of course, you can use your graphing calculator as well. Similar to before, the only way you can solve a cubing is if you can factor it. So I'm going to move the 3x to the other side. If I do that, do we agree that we have x cubed minus 9x? Okay, so I can pull out a common factor of x to the front. What am I left with when I do that? X squared minus 9. I'm going to keep going. X squared minus 9, I could factor into x plus 3 and x minus 3, agreed? So here are my 3 solutions. So let's write them down and then remember I have to find the y. How could I find the y? You could plug it into either equation. What equation looks easiest? The bottom one. Pick the easier one so you don't make algebraic mistakes. Okay? So if x equals 0, if I plug that in for y, that would mean y equals 0. That's the ordered pair 0, 0. Capiche? Okay. Does it look like these meet at 0, 0?
Looks like it.
All right, next. If x plus 3 equals 0, that would be x equals negative 3, agreed? And then I plug negative 3 in. 3 times negative 3 is negative 9. This is the ordered pair negative 3, negative 9. And this graph does look like it meets at that ordered pair negative 3, negative 9. What's the other one you think? 3, 9. So if I solved this, x minus 3 equals 0, add 3 to both sides, we get x equals 3, y equals 9. That's the ordered pair of 3, 9. Okay.